Hey, welcome to high school chemistry. My name is Rex. If you're meeting me for the first time, at the age of 13, I wrote my high school external examination and I cleared my papers. I'm 14 now, but I'm too young to go to university, so I just keep up with self-study. I'm here right now to teach you and learn with you all I've learned through high school chemistry. So let's dive in. We're going to be studying the definition of chemistry, the scientific method, uses or the advantages of chemistry, its disadvantages, and then the careers in chemistry. So let's start with the definition. What is chemistry? Chemistry is the study of matter, basically the study of everything around us, because matter is anything that has mass and takes up space. From this definition, every single thing that has mass or takes up space is studied by chemistry. So I am matter, you are matter, the air is matter, everything around you is matter. So chemistry is the study of everything. Chemistry doesn't only study matter, chemistry also studies its advantages, its disadvantages, its properties, its composition, and how we can use matter for our benefit. Chemists are constantly doing research to be able to understand how we use certain things in our environment. Now that we've dealt with the definition of chemistry, I'd like to explain to you some scenarios in which chemistry occurs. There is burning of paper, there's corrosion of iron, even lighting a matchstick has chemistry in action. So I'm going to explain the two first scenarios I mentioned, which was the burning of paper and corrosion of iron. When you burn paper, burning paper follows the law of constant follows the law of constant composition or conservation of mass, and that states. I don't know exactly what the law states. I'm going to check that. But what the law means is that whenever matter goes from one state to another, or when matter reacts with other matter, whatever it yields is going to be the same mass as what the matter was before. So if I give you a piece of paper and the paper weighs 18 grams and you burn the burning of paper is going to yield smoke and ashes and probably some other gases. Now the weight of the gases, the mass of the gases, the mass of the smoke, the mass of the paper is all going to be 18 grams. It means that when matter reacts with other matter, mass isn't lost. The mass is conserved. That's what the conservation of matter means. Conservation of mass means. And then in the corrosion of iron scenario that I gave you, when iron reacts with oxygen and water in the air or in the environment, it corrodes, or we say it rusts, and the residue is iron 3 oxide. This is a very negative effect in our environment because when we create ships and cars with metal like iron, we have to galvanize these. And galvanization galvanizing means that we coat the iron with other metals so it doesn't rust easily, because iron has a very high rusting rate or a very high corrosion rate. Now I've explained different scenarios of chemistry, we're going to dive into the scientific method. What is the scientific method? The scientific method is just a series of steps taken by scientists to be able to make breakthroughs in their field, whether it's chemistry, biology, or physics. All right? Now I'm going to give you a scenario to be able to explain this scientific method. So let's suppose you live in an sorry, you can't live in the ocean. Let's suppose you live near an ocean and a pond. All right? Now the pond is fresh water. The ocean is salt water. And it's winter. You notice that the pond water freezes at a faster rate than salt water. That is your observation. So I'm going to clean all this stuff so I can write down the scientific method. Okay? So let me just do that. The first step taken in the scientific method is observation. Observation. You observe that the salt water freezes at a slower rate than the fresh water. This is a problem. And a problem doesn't necessarily mean something that has gone wrong. It's just something that scientists like to call a weird phenomena or something that isn't normal. Okay? So now this is your observation. And then you want to understand, why does it work this way? So you propose a hypothesis. A hypothesis is just a scientific name for a suggestion. So maybe you suggest that there's a pond fairy that is always freezing the water at a faster rate than the ocean water, and you just keep proposing different hypotheses until you come up with a sensible one. So let's go with the fairy hypothesis, okay? Just to be imaginative. So you make a hypothesis. Hypothesis. The plural of hypothesis is hypotheses. The I changes to an E. Okay? So you've made your hypothesis. So let's continue with the fairy hypothesis. Now you want to test out, how does this fairy freeze the water at a faster rate than the ocean water? So maybe you do a stakeout. where you stay up late in the night because maybe the fairy doesn't come during the day, it comes during the night, like the Tooth Fairy, and you stay up late so you can see if the fairy comes to freeze the water at a faster rate than the ocean water or does some abracadabra magic. And when you see it doesn't happen, you have to go back to your hypothesis and propose another hypothesis. And when you propose another hypothesis, you keep on continuing to you keep on conducting experiments. So that's the third step, experiment. Does this make any sense? Like, you observe something and then you suggest that this is what happens, and then you want to make an experiment or you want to conduct an experiment so you can see if it happens that way. And you continue with more hypotheses, and more hypotheses until when you finally experiment and you see it gives you a solid result. Now, the good thing about a hypothesis is that it can easily be dropped and replaced by another hypothesis. So when you have experimented several times, like for instance, if I experiment, like I made a hypothesis, hypothesis could be that maybe salt water freezes at a lower rate than fresh water because of the salt in the water. So you bring 2 beakers and fill 2 of them with fresh water, place them in your refrigerator. You see that they freeze at the exact same time if they are gotten from the same source, and then you bring them out, and in one of the beakers you add salt inside it and then freeze it again, and you see that the salt water freezes at a slower rate than fresh water. Now you have conducted an experiment that makes sense, and when you keep conducting these experiments over and over again and they keep giving you the same solid result, you end up with a theory, right? A theory. And a theory, when this theory you have is being tested and carried out by different scientists and they end up with the same result, it becomes a law. So I'll give you an example of a law and a theory because a law is not the same thing as a theory. The law of gravitation states that a larger object can attract a smaller object. The attraction between the larger and the smaller object is the gravitational attraction of the larger object. So when you jump up like this, you notice that you always come to the ground because the Earth has a gravitational force on you. The Earth, as a larger object, pulls you, a smaller object, to itself. That is the gravitational attraction. The law of gravitational acceleration or gravitational attraction is a law which was proposed by our guy in physics, Isaac Newton. All right, so that's why it's always named in Newton. It's named after Isaac Newton, the law. But then Albert Einstein just recently came up with the law of relativity. It isn't yet a law, but it's still a theory. It means yes, he patented his theory of relativity, but it's not yet a law. All right, so that's the difference between a law and a theory. And now that we've dealt with the scientific method, I'd like to talk about some uses and its advantages, its disadvantages, and the careers in chemistry. Chemistry is used for so many things. In fact, its uses are infinite, right? And when we study chemistry and we use them for our benefit, we always come up with new ways to use the matter we come across. Different uses of chemistry can come in housing. So in housing, when we create skyscrapers like the Empire State Building in New York, or Burj Khalifa in Dubai, we keep coming up with new alloys and new compounds to be able to help us create stronger concrete buildings. Another use of chemistry is transportation. From cars to bikes to ships and planes, jets, and even rockets, chemists keep researching to find out more alloys, fossil fuels, and compounds to be able to help us travel faster. Another use of chemistry is in the pharmaceutical industry or the medical industry. Chemistry and medical research on chemistry has helped us to create new drugs to be able to cure more diseases and helps us to understand our diet more and how to live longer with these medicines and the food we eat every day. The last example I want to give you on the use of chemistry is in the space science. As rockets are being created with more fossil fuels and alloys and compounds, more research is done in space to be able to tell us on Earth what is going on out there. And we're able to understand the different galaxies that exist except our galaxy, the Milky Way, the different planets like Mercury, Saturn, Jupiter, Uranus, Neptune, the different dwarf planets, different asteroids, comets, and so much more. Now that we're done with the uses, which are also known as the advantages, I'd like to talk about the adverse effects of chemistry. You know what they say, that whatever is a pro is also a con, or whatever has an advantage also has a disadvantage. We've talked about the advantages of chemistry. Some of its disadvantages is that chemistry is now used for warlike purposes, or has always been used for warlike purposes since chemistry was discovered, or since chemistry was in use. Things like the nuclear bombs and weapons, better guns, and just more stuff are used in war to help people claim territory and to be able to beat other people. This is just one of the adverse effects in chemistry. Another example in chemistry of its adverse effects is drug abuse. As more medicines are being created, people are using these medicines unprescribed by doctors and pharmacists for their own psychological or for their own selfish reasons, to be able to, use them for their self-gratification and so on. The last adverse effect I'd like to talk about in chemistry is the corrosion of iron. I talked about the corrosion of iron when I was talking about different scenarios in which chemistry occurs. And I say that iron always rusts when it comes in contact with oxygen and water to leave iron 3 oxide, right? And this is a very adverse effect in chemistry because it means there's a daily loss of iron once iron is exposed to oxygen and water. This is why iron must be galvanized with other metals. Lastly, I'd like to talk about the careers in chemistry. If I may ask, what would you like to be when you grow up? If you are interested in the field of chemistry, what would you like to do as a chemist? I'd like to give you some options as I talk about the careers in chemistry. There's the nutritional area, which is nutritional research in chemistry, where chemists do a lot of research on how to improve our diets. There's the pharmaceutical industry, there's forestry, there's space science, there's research chemists, which are people who help us come up with more ways to use chemistry for our benefits. And there's so much more careers. I advise that you go online and do a lot of research on different careers in chemistry if you're really interested in its field. And now, here are the questions. Number 1, what is chemistry? Write the answer in the comment section below. Number 2, list out the steps in the scientific method, step by step. Oh, it's on the board. You could already see that. Okay, I'll give you another question. Write out at least 2 scenarios in which chemistry occurs, apart from the burning of paper and the corrosion of iron. If you enjoyed this class, please like, subscribe, and share with at least 3 people you know don't have access to basic education or who is bold enough to explore homeschool. And I'll see you in the next class.